All right, today we're going to go over solving for the variable. And to do this, we want to find out what makes this a true statement or a true equation. So what we're going to do is we're going to subtract 3.4 from each side. Since it's being added to y, we do the opposite operation. And our goal is to get y by itself on one side and the numbers by itself on the other side of the equal sign. So positive 3.4 minus 3.4 makes this 0. What comes down is the y equals, and calculate 0.5 minus 3.4, and that comes out to negative 2.9. And that's your answer for y. Now if you want to check this, you substitute negative 2.9 back into your original equation. So negative 2.9 plus 3.4 equals 0.5. And you calculate the left-hand side, and this is 0.5, and it does equal 0.5, so it checks. So this is our final answer. And you know it works because you have checked it, and when you substitute back in, it does keep the equation equal. All right, let's try x minus 7 equals negative 8. We want to get x by itself. 7's being subtracted from it, so we're going to add 7 to both sides of the equal sign. And if this is confusing, you can draw this down so you cross the equal sign. That's also okay. Put that 0. X equals negative 8 plus 7 is negative 1. All right, a quick check on the side. Plug in negative 1 for the x. Minus 7 equals negative 8. And this works. So therefore, this is our answer. Okay, next, we have negative 3 over 4y equals negative 2. In order to get rid of the fraction, you can multiply both sides of the equal sign by the reciprocal of that fraction. Because it's negative, you keep the negative sign because you want your variable to be positive. Flip that fraction, do its reciprocal, 4/3, so negative 4/3 in this case, and multiply by negative 4/3 here. These will cancel to 1. These will cancel to 1, leaving you with y. Negative 2 is really over 1. So negative 2 times negative 4 is positive 8. 1 times 3 is 3. And that is your answer. Okay, you can leave it as a fraction. You can leave it as an improper fraction. You can change it to a mixed number if you prefer. Okay, so that goes in twice in 2/3. Or you can round it appropriately to a decimal, and that's a repeating 6. Okay, to check, you take negative 3 over 4, plug in 8/3 equals negative 2. The 3's will cancel, leaving you with negative 1. The 4 will cancel to the 8. So negative 1 times 2 is negative 2. So it checks. So this is your answer. Whichever form you need to write it in, but that's your answer. All right, negative 4.3g equals 25.8. Want to get g alone, it's being multiplied by negative 4.3. So we're going to divide to get rid of the negative 4.3 on both sides. That goes to 1. So 1g equals, and 25.8 divided by negative 4.3 is a negative 6. All right, to check, negative 4.3 times negative 6 equals 25.8. Multiply this, it becomes positive, and it's 25.8. And it equals 25.8 on the other side, so this is your answer. All right, so it is a good idea to do your checks as you go through them each time to make sure that your answer is correct. All right. So let's work it up to a two-step problem. Okay, 3x plus 15 equals 24. You want to get x by itself. So you're reversing the order of operations. So we usually would multiply, divide, then add or subtract. But since we're going to reverse that, we're going to add or subtract first and then multiply or divide to get x by itself. So first thing we're going to do is subtract the 15 from both sides. This goes to 0. We bring down 3x equals 24 minus 15 is 9. We divide by 3 on both sides. That goes to 1, so we have 1x equals 9 divided by 3 is 3. Checking. Take 3 and substitute it in for x. And see if it works to be 24. 9 plus 15, it's 24, equals 24. So it checks. So this is your answer. Negative 1 minus 5x equals 29. Again, we want to get x by itself. So we add or subtract first to the other side, then we would multiply or divide whatever's next to x. So we'll add 1 on each side. And we're going to get a 0 here. But don't forget that's a negative 5x. So bring that with it. The sign in front becomes the sign of the number. 29 plus 1 is 30. Divide by negative 5 because negative 5 is being multiplied by x. Divide by negative 5, that becomes 1. X equals negative 6. All right, and you do the check the same way. All right, we'll go through one more check, and after this we'll leave them out. But you should always check your work. Negative 1 minus 5 times negative 6. We want to see if this is positive 29. So this is negative 1 plus 30 equals 29. Check this side. Negative 1 plus 30 is 29 equals 29. And it checks. So this is your answer. Next we have x divided by 3 minus 9 equals negative 12. Again, we're going to add or subtract to each side first, reversing the order of operations. So we're going to bring that 9 over. We have x divided by 3 equals negative 12 plus 9 is negative 3. We're going to multiply by 3 on each side to get rid of the denominator, because that's really over 1. This will cancel with this. Okay, so x equals negative 9, and that's your answer. Okay, if you plug it back in, it will check, but for time's sake, we'll leave it. But we will check the last one because it looks a little more complicated. Okay. Next, we have 9 plus the quantity of c plus 3 all divided by 5. This is all together, so we can't pull this apart yet. So we have a quantity of c plus 3 divided by 5. Adding 9 to it, and then it's equaling to 7. So the first thing we want to do is get rid of the 9 that's being added to this so we can get c by itself. That 9 is a positive, so we're going to take the opposite of that, which is a minus sign, so a negative it looks like. So we're subtracting 9. That's 0. It brings down c plus 3 over 5 equals 7 minus 9 is negative 2. And now what we're going to do is we got to release the c, but c plus 3 is being divided by 5. So we have to get rid of the 5 denominator or divisor, and so we can free up the numerator of c plus 3. So this will cancel with this. Remember that guy's over 1. So we get c plus 3 equals negative 2 times 5 is negative 10. Whoops. All right, and now what we're going to do is subtract 3 on both sides. And we will have 0 here, and c equals negative 13. All right, for our check, okay, this one's a little more complicated, so we'll do this. 9 plus, we're going to put negative 13 plus 3 all over 5, and we want to see if it equals 7. Order of operations now, this is all numerical. It is no variables in this check. So we have to keep the 9 plus. Negative 13 plus 3 is negative 10 all over 5 equals 7. Now you know a fraction means division. So we have to do this first because we divide before we add or subtract according to the order of operations. So 9 plus negative 10 over 5 is negative 2. And then this equals to 7. 9 plus negative 2 is 7, equals 7. And so it checks. So this 13 equals, C equals negative 13 is our answer. Okay? That is how you work on 1- and 2-step equations and checking.